So welcome to yet another OpenChain webinar. Today we're digging into SBOMs again. We're going to look at SBOM visualization, and that's an alternative approach to reviewing SBOMs that may be of interest to people. Naturally, most of us are aware of the NTIA minimum requirements guidelines out of the US. But there is increasing discussion and potentially future regulation about SBOM in many jurisdictions. One example would be more and more material about SBOM is being published by Japanese government agencies. We see discussions in Europe about SBOM adjacent to things like the CRA. So, ways to manage SBOMs, to visualize and review them, always interesting. Before we get started, I'll just flag, as we always do, the Linux Foundation antitrust policy. You can find the full policy on the Linux Foundation website. And if you have any questions, if you're from an LF member company, you can ask them of our counsel, Andy Updegrove. If you're not from an LF member company, please direct questions to your own counsel. With that formal bit out of the way, I just wanted to give a very brief introduction to Andreas, who's leading the discussion today, founder and CEO of Bitsy. He has long been a presence in managing open source, the business knowledge, processes, and activities in the German language sphere. Andreas and Bitsy have also been engaged with international open source management, not least as an official partner of the OpenChain project and supporting adoption and use of our ISO standards for open source business process management. For those of you who are new to OpenChain, we of course build the ISO standards for open source license compliance and open source security assurance. The reason SBOMs are interesting to us is that they are one of the first requirements in both of our ISO standards. You first must be able to know what is in the software to make decisions about how to manage it. Enough of the intro from me, though. I shall hand over to Andreas to begin his screen share and presentation. As previously discussed, Andreas is happy to collect questions and answer them at the end. So if you have questions, please feel free to leave them in the chat, and we'll get to them as soon as the presentation is over.
Hello, good morning, everybody. You should now be seeing my screen.
Yes, it's perfect.
Perfect. Okay, welcome, everybody. My name is Andreas Kutula. I'm the CEO of Bitsy, and I'm delighted to have been invited to present here. Today, I'm presenting the result of a research project that we did together with the Bonn-Rhein-Sieg University of Applied Sciences, which is near Bonn, and a bachelor's thesis that we supported that was run at the university. And the whole project was supported by the Federal Ministry for Economic Affairs in Germany as part of a CIM project. So what is an immersive experience? The term immersion describes the act of submerging yourself into an environment. This experience puts people into a fictional world and is similar to the experience of submerging into the sea or reading a very interesting book or watching a movie. We have done SBOM or FOSS analysis for quite a very long time, and we have seen similar challenges arising again and again. The amount of data that you have to understand is constantly growing. Dependencies are not immediately apparent, and it's not easy to get an overview of the entire system. The flood of information, the scope, the complexity, and the interpretation of the data are very difficult for many customers to understand. And at the same time, it is becoming more and more important to fulfill new legal requirements, like in the US, the Executive Order 14020, or in Europe, the CRA, DORA, or NIS. So the idea we need some simplification of the SBOM through visualization. And BitC in our history, we have done a lot with visualization of software architectures. And we were trying different methods of what we can do with an SBOM to make it easier understandable, and so that people know if there are any risks or not, or all the applications that they have. So imagine, for example, you are some kind of security officer and you receive an SBOM for a new product that is to be introduced in your company. And the SBOM is several hundred pages long. And you are now to decide what is to do, what do you need to do for implementation? Is it okay, or are there any risks? And how do you handle that? How do you know that there are any risks? So that's basically the start of our project. And to get started with the presentation, I would like a short survey to run that with you. And for that, please take your mobile phones and scan the code that you see at the lower left corner. And then we want to look at, what do you think, what is most difficult about open source management? What is the most complex task that you foresee? So is that if you have an SBOM, is that the assessment of security vulnerability, export restrictions, or the evaluation of the sustainability of open source projects? Is it the creation of the SBOM itself? Is it the legal assessment of the SBOM? Or is it the governance of the whole SBOM management, the open source management, the processes and the training? So I see some first answers. Just scan the code and then you can select whatever you think, and I'll just give you some seconds to answer. Maybe 10 more seconds. I think most of the auditors see that it's quite complex to assess once you have an SBOM, what to do with it. Okay, thank you. I think we have first place, we have this assessment of the security vulnerabilities, export restrictions, and the sustainability of the open source components. And we will have a look at that later on in the presentation. Thank you for your support so far. So if we look at open source is everywhere. An experienced developer does not write code from the scratch, but he knows where to get software, commercial packages, and open source for development. And there are many reasons to do that. So open source can improve productivity, can shorten development time, reduce development costs. And also with AI, it's getting more and more easy to write code. And high quality code can be generated at lightning speed using open source repositories, and just glue all these together. And we see that across all different industries: automotive, embedded, IoT, healthcare, finance, and also across all different technologies on Linux, Windows, embedded, software as a service. So wherever you look, you have open source. If you even look just at a simple electric toothbrush or some cooking appliances like the Thermomix, it's a appliance very popular in Germany. They contain large amounts of open source. So generally, use of open source is great and good. To manage open source, it's also important to consider some of the risks that you may have. And as in any software, of course, there may be some cybersecurity risks. There is some intellectual property you need to respect. There are license requirements with obligations that you need to follow. There may be export restrictions in the code, especially if there are encryption algorithms. Sometimes you may get incompatibilities between different licenses when they have applications that you cannot fulfill at the same time. And there may be operational risks that you have an open source component, for example, which is not supported anymore by a community because it's very old. To be able to do all of that and to manage the risk, you need to know what is in your code. So you need this SBOM, and then you can decide on what you need to do. There was a recent study by the Bitkom group in Germany, and in that survey, the result was that 60, 70, or even up to 90% of the code that we find today is open source. And I generally assume you know all of that, and I won't elaborate on that. We'll go into the details of the visualizations in a second. If we look at the SBOM, the software bill of materials, this SBOM specifies the inventory of the components used to create a software artifact. It is comparable to an ingredient list of a food package, so everybody can check a label to avoid food that may cause allergies. So you can look at the SBOM and you can decide if your organization or individuals want to have this open source component, or if there are any obligations that would harm your strategy. So the concept of the bill of materials is very well established in the traditional manufacturing as part of the supply chain management. A manufacturer uses a bill of materials to track the parts it uses to manufacture a product. If defects are later found in any part, the affected product can easily be located using the bill of materials. You may know that, especially in the car manufacturers, they know from every single screw that they have in a car where it comes from, in which car it has been put. And when there's any problem, they will just call out the driver of the car, ask him to go to the next garage, and the car can be repaired again. With software, what we see today, it's still very different. Many companies don't know what is in their code, in the whole artifact. And the software bill of material is to manage that for the software industry as well. So the SBOM is a formal data set that contains commercial and free software components included in the product. It shows you the dependencies on third-party components. It makes it transparent and helps manufacturers, security researchers, and users to monitor vulnerabilities and much more. The German Federal Office for Information Security, the BSI, has published technical guidelines on the minimum requirements of an SBOM. So it should, of course, have the name of the component, the supplier, the author, a timestamp, a version, any unique identifiers, a dependency relationship, a license. And sometimes we can see there may be much more information. So now imagine you are this IT security officer that I talked about that who has to take a decision. Can I install that product, and what do I need to do? Are there any obligations? So you get the SBOM, and it is very, very long. What do you have to consider? What are the legal aspects? What are the security impacts? What about export control, maintainability, and operational risks? And analyzing a software bill of materials is like reading the terms and conditions. You know that it is very important, but when you see how long it is and when you see the first page, all you want to do is just click accept. Or you will say it's fine, but you know that will not really help you. And there are many different parameters you need to consider. So first of all, you need to look at all the components. Then you need to look at the licenses. There may be copyleft licenses, commercial licenses, permissive licenses, and other copyleft effects. You need to look at the security gaps. You need to look if there are impacts on patents. We have that, for example, with the Apache license. There may be export restrictions. So depending on how you use your product, you may not be able to use some of the open source components. Then I mentioned the incompatibilities that you can have between licenses. For example, GPL and Apache. GPL requires you, if you put it in a product, that you deliver it as a GPL at the end. Apache says you can do everything. It's very permissive. However, that part needs to be Apache. And then you see you cannot fulfill both of the obligations. And you need to find ways how you can manage these incompatibilities. Very important are all of these operational risks. There are millions of open source components, and most of them are well supported by the community, but there may also be components where there's no maintainer anymore. And when you use that component and there is a security vulnerability, you need to know where can I get support. And if no support is available anymore, you may have a higher risk. And it's good to know that beforehand and not only when a security vulnerability is found. Very often, it's also important to understand how are the open source components linked together. Do we have a static linking, a dynamic linking? Is it just a reference call or a Linux system call? All of that you need to analyze while reading the SBOM. It may be important if it's a whole component or just a snippet. It may be important to know if the component has been modified, because different licenses act differently once you modify it. It's important to know if it has been generated by AI, yes or no. And for some people, it may also be important to know if it's already legally approved or it needs to go into a legal assessment again. So what we wanted to provide is basically a simple overview with filters simulation that simplifies the evaluation of the SBOM that you have. And we thought a graphical representation of the software bill of material is extremely useful to do that. You all may know the SBOM format as a long text list in different formats like SPDX or CycloneDX, or there are many different Excel styles or other styles you can have. With a picture, it may be easier to understand what is in there. So think of an SBOM as a detailed map that depicts the entire software landscape of a project. Just like a map shows the different geographical elements, just as cities, roads, rivers, and mountains, the SBOM visualization shows the different components, dependencies, relationships within the software, and specific characteristics of each of the components. The advantages of the graphical representation are that you get a quick overview and clarity. So you have a visualization of the software components and their dependencies, and you have a quick and intuitive understanding of the overall structure. You can have a simple navigation that helps developers, project managers to recognize the connection between the components, identify possible weak points, and understand the effects of changes. You can, in the graphical representation, easily identify dependencies, and you can see which components depend on each other, where are potential shortages or risks, and which parts of the software are potentially critical. It can help you for communication and cooperation, because as the whole team, you know what you speak about. Whoever is involved, he has the same view of the SBOM. And the graphical representation helps maintainers to see, again, the dependencies that you have, and it allows you a clear planning. So the graphical representation of the SBOM is like a detailed map that shows the terrain of the software landscape clearly and comprehensively. It makes it easier to navigate through the complexity of the software, supports the recognition of dependencies and risks, and promotes communication. In the following, I will show you all the different elements that we defined. But before we start, I have some figures that I would like to share with you. It's how the usage of open source increased in the past years. We started around 2012 with the open source analysis. And in a typical package or a typical project at that time, we found 200 different open source components. And you can see over the years, that number increased a lot, and there are many reasons for that. There are now easier package managers that have many more dependencies. And a decade or 2 decades ago, we often had very big libraries like the Boost library that would give you hundreds of functions. That has now been replaced by 100 of different components from different repositories, all with different licenses. And that makes it more complex for the legal teams to understand what is going on. The package managers make it easier for developers to keep everything in a state that it's still working and compilable. Modern programming languages use more and more small components as opposed to the large monolithic components. And there has been a big leap in the last few years with new popular ecosystems like NPM, Ruby Gems, PyP, and others. They are rapidly increasing the number of dependencies. In the last year, we typically saw around 3,000 open source components in a typical project, and we suspect the number will even grow further. So the task is, you need to somehow manage more than 3,000 components and all the different characteristics I just mentioned before, like the license obligations, security vulnerabilities, export restrictions, the operational risk, and so on. And then you can imagine it's getting a very complex task, and it's almost impossible to do that with a list just by yourself. So to get started, we want to have a very simple and easy to understand mechanism for the SBOM. And our designers first looked at what can I vary, what can I show. So of course there are the components, and then I can vary the shape, the size, the color. They can overlap. I can have different icons, sharpness, line style, the position, typography, some patterns that I can apply. And what we always want to have is produce a visual language whose grammar the user can understand very quickly, and that is easier to understand than plain text. And that visual language must be clear, easy to use, easy to understand, easy to perceive, and holistic. So we want to have that it covers all the different aspects that I just mentioned. So we start from the very beginning. A component will just be a rectangle with the name and the title, and we will have a small connector on one side. And in this rectangle, we can show already if it is a snippet from a component or if it is a full component. A full component will be the full rectangle. If it's a snippet, then some part is just cut off at the bottom. Then you can easily differentiate that in the visuals. For the obligations from the licenses, we use a color scheme like in the traffic light. So that can easily guide you if we have a strong copyleft, a weak copyleft, or a very permissive license, or if we have a license with some special features. So we use red whenever we have a module that contains some copy theft license, and we can even differentiate in the shades of the red color if it's a strong copyleft or a weak copyleft. Then there may be many licenses which have some special features, commercial licenses or licenses which have been modified, and some have some additions or exceptions. So these we would color in yellow, and green means it's a permissive license where you can use it and you don't have these copyleft effects. Yellow would mean most likely there's some advice that you need or somebody needs to look at that component. So with this color scheme, you get a very good first view on the different licenses, obligations that you have. Then, of course, it's very important to know if you have any security vulnerabilities in the components that you use. And we use a red stop sign for that. So if there are no security vulnerabilities, it's absent, it's not there. And as soon as a component has a known security vulnerability, you will see the red sign, which means the component is vulnerable. And we can also show the number of vulnerabilities that are known for that component by just adding a small number inside. And you know there are 3, 4, 5 known security vulnerabilities. Similar for export restrictions, we have this attention sign with the exclamation mark. When you have some export restrictions or encryption algorithms, we will just have the sign at the side of the module. As mentioned, it may be very important to know if a component has been modified or not by the developers, because several licenses like MPL, EPL, they have different obligations when you modify. We show that with the small pen. And that shows that the component has some modification and is not the original anymore. Then there are several other aspects that we want to show. For example, if a legal department has already approved a component, we have this small blue question mark if that is not the case. And if it has been legally approved, then we have the small question mark. Then if there is an impact on patents, we use a hammer, which you know from the attorneys. Then if there is any operational risk, we have that exclamation mark in a star. That shows that the component may not have a big supporting community anymore, or that there are no updates in the repository, in the hosting repository since a long time. And we can also show if the code of the component contains code that has been generated by AI. That's the blue bar at the top. So there's lots of information that we have with colors, with symbols, with small images that can all be put in a component. Then, of course, it's very important how the dependencies look like and how the linking is done. So if we look at the static linking, which often happens if you just copy-paste code, or if it's somehow statically put in your system, then we have a solid line connecting the different components. If it's dynamically linked, then we have a dotted line, which you see on the right-hand side. So it's, or if it's, you can easily differentiate between the different linking types, what you have. There may be special cases, like in Linux, you know, it's very important to follow the syscall. So if you call the UAPI, then your part of the software is not affected by the GPL. However, if you do a direct call into the Linux kernel, then you may have a copyleft effect. And to show that you need to be careful, we have that small exclamation mark in a yellow attention sign again. So we can show how, if the dependencies may cause any risk. You know, there are many further important information parts on the open source components that may be important, and those we have in pop-up in a pop-up menu, where we can cover the software area, parent name, we can get a hierarchy, the license type, the full license text, the URL where you may get the component, the full list of vulnerabilities, the files that are affected, copyrights, and all of that, we have the details in a pop-up that you can easily show. Okay, I see there are many questions already. That is great. I would just finish off and show you some examples, how that looks like in a real life example. And then we can go into the details in your questions. So we took a very big project, the Google Chromium, to show how all of that would look like. And we did some additions to show all the different cases that I just mentioned. So the let's have a first look, and don't be shocked because Chromium is really big. And you can see there are many components all together. And from a first view, it's still not easy to understand what is all going on. But you can now filter and search and zoom in and move around. And then it is getting very easy to understand your SBOM easier. So if I zoom in, you can suddenly see all the different components that we have in this Chromium product. You can see the different licenses. You can see how they depend on each other. You can see if there are any export restrictions, if some parts have already been looked at by a legal team. And we can move around and see the dependencies in the product itself, how the components are put together. And if you don't remember what the different images are all about, there is a small agenda that can be put in, that is shown. And the first view that you saw, that is it's called force graph. We also have a directory view. Then that's even easier to show how the dependencies are composed together. This is how it normally looks like. And now I think the fun part starts when we can filter or run simulations and see how different components act together. So the first thing I want to show is the search filter. I can just search for anything, like for specific licenses, names, part of the names, specific characteristics. For now, we have just looked for components that contain the name test. And you can easily see some light green components in this big system. They are now easily identifiable, and that you could search for copyleft licenses or for modified licenses or licenses which have no policy clearing, and quickly see that. Here we have the different filters that you can put in. For example, here I was now looking at all the components that have some security vulnerabilities. And then you can quickly see and evaluate the components if you need to install a patch or replace the component or need to go to a newer version. Or we can look at all the components that have a copyleft license. So then all the other components are removed. And you see the remaining licenses on the components with the copyleft licenses. Here we filtered for security vulnerabilities. Or we can do some simulations when we know we have a license that has a copyleft impact and we want to see how is the effect on the whole system because of the dependencies. Then you can suddenly run the simulation and you see that which components are affected because of the linking that they may have. And we can run simulations on, for example, incompatibilities. You can put in a list of licenses that are incompatible with each other, and then you would find the dependencies with a small flash indicating that you need to separate that part of the license. That was a very quick overview of the research project that we ran and the tool that we had. So to summarize, you know, open source is everywhere. It's almost impossible to write code without the use of open source. Open source is very good. Open source has some risks that you need to manage. And if you just look at the SBOM, it's very complex to run through that. And with this visualization, it may be easier to understand what we have. So the visualization is like a state-of-the-art navigation system that helps you navigate through the complex streets and neighborhoods of your SBOM. And I think the highlight of the graphical representation is that it can clearly present complex information interactively and comprehensively. It makes it very easy to navigate through the landscape. You can easily identify risks that you may have, and they may vary a lot depending on the model, how you use the open source component, on the distribution model, if you just use it internally, if you have it as a software as a service, or if you have a product that you distribute. So all these scenarios may have very different effects on the use of the open source that you have. So the visualization helps also our security officer in the that I mentioned in the beginning to quickly localize potential risks. You can do that automatically with the tool. And we also saw in the beginning when we did the small survey, I think most people selected it's most difficult to understand what is in an SBOM. And to understand what is the impact, where do I have risks, how to manage that. And this is exactly what we wanted to address with our product. So thank you for listening, and I now go through the questions. I think one of the questions I saw several times is this tool available to test to try out on our own. So we want to publish this tool as open source, so everybody can use it as he wants. We have right now a simple format, an Excel format, where you need the SBOM that reads it in, which needs the different parameters, and then it will automatically put in this visualization. We also are currently working, or we just started with a nice project together with the in Europe, which was funded by the European Community, which will address the make it easier for the Cyber Resilience Act to manage that for companies, and we intend to put all those visualization as part into that product. So right now the tool is not yet available as open source. We are just polishing it a little bit. So maybe in November, December timeframe, then I will share a link, and then you can also try it by yourself.
Now we have a ton of questions. Would you like me to read out a few of them and then you can reply as we go? What do you think?
Yes, that would be best, because if you can pre-sort it.
Okay. Now, everyone, if I don't get to your questions in order, bear with me. What I'm going to do is pick up some of the kind of the main simple questions and take us through it. So one that came in from Jimmy was, how do you define impacted on patents? How do you define the impact of patents?
So here, I'm not a lawyer. I can just say what I understand. There are some licenses that have impacts on patents. Like in Apache, there are some clauses that if you have patents, you have several obligations, or you need to follow some guidelines. This is what we mean by it has an impact on patents.
All right. And a question from Mattia. How does one find out if a piece of code was AI generated if it's not tagged as such explicitly? So that's a question which is much bigger than just visualization. But is there something that you and your team and your collaborators discussed around that topic?
So of course, I'm pretty sure it cannot always be found out automatically. Either it can be tagged that it was generated. There are scanners that look for snippets that would detect code that is open source, but then still you would need to know that it was AI generated. So we don't have a mechanism added that finds that. We can just, if you have that information, then we can display it.
All right. And a quick follow-up from Jimmy on the patent question. So he just wanted to clarify. So the tag about impacted by patents, is it correct that that is when the license explicitly talks about patents? So the license says something about patents and therefore it's flagged impacted by patents. Is that
Exactly.
understanding correct?
Yes, exactly. Yeah.
Okay.
And you can also configure the tool. So if you say specific licenses, you want to show that symbol as well. Maybe you have a legal team which says, attention, in this license, we also have an impact on our patents. It may depend on if you produce hardware combined with software or not. That may have different effects. Then you can just configure that yourself.
Now, there's an interesting comment from Ole, which is just a side note, that Cyclone DX community has recently started a work group to map patents, and if people are interested, to join that effort. Okie dokie. Next question. Anthony asked, is all the information in an SBOM being visualized? His personal interest is understanding how export restrictions might be specified or visualized regarding SPDX or Cyclone. Now, Umo jumped in and said that for SPDX, we're working on addressing export control with operations profile. Anyway, long story short, is all the information being visualized? His interest is export control. Is it more limited at the moment? And I suppose the next question is, will it be expanding in the future? Could a community help expand what's visualized?
Yes, of course. You may have seen that the characteristics that we visualize, there are a lot. And many SBOMs do not contain that many aspects. So it depends what tools you are using. And all of that we can then visualize. And sometimes you also may need different tools to bring all that information together. And especially with the export control, yeah, there's the working group where we were looking into enhancing the SPDX for covering export restrictions. I know of some tools that can have an additional tag with the export control. For the, we just visualize it. So you somehow need to get that information and in a format that we can read. And I hope that answers the question.
And we have plenty more, don't worry. One came from Jeff. What processes or tools are you using to generate the SBOM, which we saw shown in Chromium today?
We use a variety of tools. We have some commercial tools and some open source tools. The tools we typically use when we look at the open source, it's the scan code together with Fossology and ORT. And from the commercial tools we use, it's the Flexera SCA and the Black Duck tool chain. And so all of that you can use to get the information that we then put into in this graphics.
And there's another question, well, a comment and question. Andrew, I'd be interested to know if the dependency relationships are stored in a graph database. Is any of this project based on, for example, the Quartermaster project?
No, it's not. So we take that information just from a table.
Yep. One in from Jimmy again. Do you provide a classification of licenses, or is that user configured? So, who determines if a license is copyleft, you or the users, etc.?
Yeah, the user can configure everything. We have a suggestion where we have like the AGPL or GPL is strong copyleft, and the other public licenses is weak copyleft, and then many permissive licenses like the MIT, BSD, and so on. But you can configure that. I had some discussion with lawyers and they immediately came, we need much more colors. They wanted to have not only 3 or 4, but they have many shades, so you could configure that.
Now, one that came in from Mattia is, what's the number of components you tested this view on? How many components were in the demo? And I think that's perhaps a leading question, going to try to understand how many components equals X complexity of visualization. What did we just see?
I think it's a couple of hundred, maybe 400 or 500.
Yeah.
Just a rough guess.
All right. A follow-up directly on that one, which comes from Jimmy. How large is the database, as the current database of licenses analyzed and assigned colors? Because as you know, there's a lot of open source-ish, open source but never submitted for review licenses. So how big is the database that you use?
So at the end, we map it all to 3 colors. And we have maybe it's around 1,000 different licenses that we have in the database.
Okay, that's a lot. I'm just going to scroll up. I saw something from Thomas and I have to go and find it, but there's a lot of stuff happening in this chat. Okay, Thomas had a comment. Oh, his comment was about processes or tools for generating, for instance, what we saw for Chromium. And Thomas noted that, he's generated SBOM for Chromium with the OSS review toolkit. But there was a challenge that C components were missing package data. And Anthony just jumped in that he generated an SBOM for a Chrome browser on Ubuntu using distro to SBOM, and that had 150 components based on the information in the package manager. Neither of those are questions, they're just observations that trying to break down a large code base like Chromium can be quite challenging, and sometimes the tools might miss data. Let
Yeah,
me,
so we never rely just on the package manager data. We look directly into the code, and then you will find much more. And that's with the commercial tools, where you can also detect these code snippets that are in there. And
Yeah. Um, Alan over at, hey, Sony. Alan over at Sony had a question. Does the tool cover AI licenses and SBOMs?
so right now, for example, which licenses do you mean?
I think this would touch on licenses, and correct me if I'm wrong, Ellen, but just by way of example here, I'm just going to pick on, what if you have Llama and do you include things like the Llama license or more explicitly open source AI licenses, which appear to move closer to the definition of open source? So, that new category of licenses that we see appearing
We don't have that in there now.
at the moment.
We
But
would
as I
need to
understand,
add it.
yeah, as I understand it, what you've done is you've built a database of around 1,000 licenses, and that could be extended in the future.
Yeah. But then you need
Um,
to see how you map it. We may also consider if we need some new symbol or new color code. And when you look at the icons and symbols and colors that we used, that was a very long process between the designers and the developers to come to a point what is easy to look at, what's easy to understand. And the designers had great ideas what they can do with colors and lines, and but at the end it was not intuitive what we did. So that were many rounds, and we took to lawyers and asked them, do you understand that very well, and what could we change, and which symbols are easier? So that is the state where we are right now, what we shared. And I think it's an evolving project as well, as there will be new licenses or maybe some new characteristics that an open source component can have, which may be important sometime in the future. And then we need to see if we add a symbol, a sign, or some other mechanism to display that.
and that really touches on something that Jeff and Steve mentioned. Jeff was talking about for colorblind people, maybe a color neutral pattern would be useful, and Steve was talking about varying the shape.
Mm.
And that sounds like potentially interesting refinement items. Uh, yeah. Okay, I'm trying to pull up here and see what we got in terms of extra questions. Leonard, what information do you extract out of, for example, SPDX described software? So yeah, that kind of goes back to the how much do you pull out of something like SPDX? Because SPDX, of course, is a pretty big, pretty big SBOM format.
Yeah, so we pull out what we just showed, and all the additional information which you do not see in the visualization, we try to put in these pop-ups where you can cover additional information.
That's great. Okay, so then we're kind of through most of the questions. What I'll do is I'll just note that there's ongoing conversation in the chat, both directly and not directly related to what we're doing here. So for example, in the chat, conversation continued on the impacted by patents. And one thing that came up there was in the visualization you've got, which again is user controlled, users set their parameters. In the visualization you've got licenses which talked about patents you flagged as impacted by patents. A side conversation, not central to the visualization or what we're doing here, came up beyond that clarification where Ole flagged that Cyclone has a work group about mapping patents. Jimmy flagged that as a user, he'd probably want to stay away from potential normative information regarding patents and SBOMs. And then we had a couple of more things. Uma was saying similar discussion in SPDX operations work group. Um, yeah, There's
Yeah,
conversation, that kind of
yeah, I
thing.
have one thing
So
to add here with the
that's not for us really today. That's just a side note that they're going down that rabbit hole. That's their rabbit hole. Let's leave them there. And then on the other rabbit hole, Chromium, the discussion was ongoing about, scanning Chromium, getting SBOM out of it, the problem of C components using ORT, then talking about distro to SBOM on Chromium and questions of how do you deal with compiler flags and so on. I'm just mentioning this because that conversation is happening in the background. If you're watching the recording, it gives you the idea of what goes on with the live chat in the corner where people take a break out and go with it. Pulling right back to the core, people have been impressed with the visualization. For instance, Andrew said it's great to see an open source project or future open source project focusing on user experience. And some key questions like, what about the license database? How does that work? Well, it's a file of licenses. Can we change it? Yes, you can. The user defines ultimately this stuff. So it basically sounds like what we see here for the first time today is a potentially flexible SBOM visualization codebase that allows people to set their parameters of what their rules are. This license means X to me. For instance, do I combine GPL2 and Apache? Free Software Foundation says no, or as in the chat, as Mattea pointed out, there have been analysis which say yes, it's fine. One important one being Pamela Chestik's paper, which came out earlier this year. Anyway, Andreas, that's remarkable. Can you keep us up to date on when the service is more broadly available and when it might be open source?
Yes, sure, I will let you know. And if somebody wants to try out immediately or wants to have something before we are ready with a nice version, just let me know and we'll see what we can do for you.
Yeah, no, absolutely. This is really good. And everyone who doesn't know how to contact Andreas, don't worry. Just reach out to OpenChain. We'll put you in contact with him.
I have to put it
Yeah,
here.
you've got one volunteer, by the way. Mattia over at LifeRay is happy to help test it on tens of thousands of packages, a smiley face. So you have your first collaborator.
Great, thank you.
Brilliant. And Jeff just flagged when this is available. Please flag it on the uh, SBOM list for OpenChain, which of course they're meeting in 8 minutes. They're going to have one of their community meetings. If you're on this call and you think, gosh, the SBOM study group is meeting, I didn't know that, please subscribe to our mailing lists. And just as importantly, I'm going to send the dial-in, which is already working, and you'll go into the waiting room. Andreas, thank you so much. That's fantastic. A wonderful, wonderful webinar. Deeply appreciated.
Thank you for listening.
Bye bye, all. Take
Bye bye.
care.